At this point, we're ready to do our lighting calculation. So to do the daylighting, you can use the eco light calculation node. So just like before, we're going to link this into our process so far. Before you do this, you definitely want to make sure to set the boolean to false, because this lighting calculation is one of the most time-intensive calculations in Ecotech. So if you don't set that to false, it's going to trigger and start the calculation right away. You can see it's performing the calculation here. If you need to cancel out, you can usually click on this Ecotech, and even if it doesn't launch the program, you start hitting escape, and it will basically break out of that calculation and bring you back to Grasshopper. Okay? So here we'll set this to false while we make the connections, so nothing will trigger. For lighting calculations, again, you can keep a lot of these things at default, but you should go through these options. Some of them are really useful. Here there's an option for calculating the lighting based on a grid or point. There's this other option in Geco where instead of creating an analysis grid, you can just bring in points, and those don't have to be in a grid. They can be any points in your model, and it'll calculate the light hitting each point, which could be useful if you're dealing with different kinds of geometries and you want to specify exactly where the calculation happens. I'm not going to do that today, but you can experiment with that on your own. It's pretty much the same process. Here you select whether the analysis happens in 2D or 3D. We're going to keep 2D, and then various other options. The one input that we're going to want to change is this P, the precision, and this deals with the level of accuracy of our analysis. And as we set this up, we want to start at 4, low precision. Basically, the higher you go, it gets substantially slower in terms of analysis. So your final analysis, you want to be really accurate. You can set this to full precision, but it's going to take hours. For our case, while we're testing, we're just keep this at the lowest resolution. All right, so once we have that, we can hit execute, and it's actually going to execute this analysis. And I just want to show Ecotech here because you can see this analysis happening dynamically as soon as you hit go. So I'm just going to move Rhino over and I'm going to hit run. You see it regenerates the geometry, and here you can see the daylight analysis progressing. So it basically calculates this over the whole floor, starting at one end, ending at the other, and it gives you a status bar about its progress. Once that's done, you can see the analysis here, and it's calculated the amount of light actually getting in through our facade into our floor. So again, this is just an Ecotech right now, but we can always import the results and visualize them directly within Grasshopper. To bring in this grid into our model, we can use the eco or the import analysis grid node, which is eco grid request. So before we were bringing in just the data about our panels, we were using another node called object request. Here we're just bringing in the color and the information from our objects. In this case, we're actually bringing in the geometry of the grid. Remember that when we did this fit grid component, it didn't actually create any Grasshopper geometry. It created this analysis grid in Ecotech, which right now only exists within Ecotech. So with this node, we're actually going to bring the geometry itself and recreate it within Grasshopper and then color it with these colors. So this component, import analysis grid, will actually bring in the grid as a mesh into Grasshopper. So here we'll chain this into lighting calculations. You see it's created new geometry in our model, and this was the actual geometry of the analysis grid. At first, it will only visualize the points, but just like before, it's brought in a lot of useful information from the analysis, like minimum, maximum values, and the colors, and also all the information to recompose the grid. And to actually rebuild the grid within Grasshopper, there's another component in Geco called Eco Mesh Grid, and this will actually rebuild the mesh, the analysis mesh, as a mesh object within Grasshopper. So here it goes one-to-one. We plug the points into the points, the U and the V values there, and it'll start to create this mesh. We want to plug the H into the H, and this will basically give us the height of the mesh. And then finally, we want to plug the RGB values into the color component, which will give us the actual colors of the analysis. There. And at any point, we can start to mess with this and change this to really change how this geometry works. For instance, if we don't like these colors, we can always take the RGB values, plug them into a HSV component, and change the hue to shift what the colors look like, or we can just deconstruct it completely and give it their own colors, or just change them to black and white. There's a lot of things we can do. We don't really have to accept the Ecotech colors, which is another good benefit of this workflow. So you can see what's happening here. Basically, the geometry is letting sun into certain parts of the building where there's more openness, and it's keeping out sun in other parts. So we can quickly visualize now, because this is all automated, how changes to our facade system affect the daylighting inside of that floor. So if we set this to false, we can play with a slider, maybe create a lot less openings. Set it to true again. It'll rerun the entire calculation, so it'll take some time. Okay, so that is daylighting with Ecotect, with Geco and Ecotect.